Now we will continue the same or discuss some other examples. Let us see. Solve the recurrence relation say f n plus 2 minus 4 times f n plus 1 plus 3 times f n is equal to 0 with the condition f0 is equal to 2, f1 is equal to 4 and n is greater than equal to 0. It is a totally different recurrence relation. So why here each term starts from the value greater than n plus 1, n minus 2. There are no terms which are less than n. It is totally different from the previous recurrence relations. It will be also solved in the same manner. What the differences will exist, we will see. Here we consider the given recurrence relation fn plus 2 minus 4 times fn plus 1 plus 3 times of f of n is equal to 0. Table number 1. Our generating function is sigma n varies from 0 to infinity fn into z raised to the power n, that is equal to f0 plus f1z plus f2z square plus f3z cube plus so take it number starting same steps. Multiply both sides of 1 by bs means both sides by z raised to the power n. We see fn plus 2 into z raised to the power n minus 4 times fn plus 1 into z raised to the power n plus 3 times fn into z raised to the power n is equal to 0. We can calculate them separately. That is, or we could say, first of all n is equal to 0, 1, 2, 3 and so on. Because here our variation it starts from 0 as we can see in the each term of the recurrence relation. And sum what we get, that is sigma n varies from 0 to infinity f n plus 2 into z raised to the power n minus 4 times sigma n varies from 0 to infinity f n plus 1 into z raised to the power n plus 3 times sigma n varies from 0 to infinity f n z raised to the power n. Now we consider it number 3. Now we can find the solution of each term separately or simultaneously. That is sigma first term n varies from 0 to infinity f n plus 2 into z raised to the power n. Now we start substituting the variation from 0 to infinity. Here we put n is equal to 0. We get f2 into z raised to the power 0 plus if we put n is equal to 1 we get f3 into z raised to the power 1 plus so on. That is equal to f2 plus f3z. Now again we compare this bracket with our generating function this. the situation is totally different from the previous situation, previous problem. Here F2 is alone. Here F2 contains Z square. Here F3 is with Z cube, F3 is with Z. Now in spite of taking the common, we multiply and divide by Z square. In this case, that is F2 Z square plus F3 Z cube. That is the difference between previous reconciliation solutions and this. No, that is equal to 1 by Z square into, from the given we see this bracket is equal to GZ minus F0 minus F1Z. Similarly, in the second term, sigma n varies from 0 to infinity Fn plus 1 into Z raised to the power n. To start putting n is equal to 0, we get F1 Z raised to the power 0 plus F2 n is equal to 0, 1 plus F3 Z square. That is equal to, we see F2 is with Z square in the given generating function and F3 is with Z cube. So what we will do? Multiply and divide by Z. It will become F1Z plus F2 Z square plus F3 Z cube plus so on. Then if you compare with this, that is equal to sigma n varies from 0 to infinity Fn plus 1 into Z raised to the power n is equal to 1 by Z into G Z minus F0. Now for the third term, sigma n varies from 0 to infinity Fn Z raised to the power n. To put n is equal to 0, it is F0, n is equal to 1, F1 Z1 plus F2 Z2 plus so on. Here we see, compare the both brackets, that is equal to G Z. Simply. Now we compile all the terms according to the condition 3. We say this Fn plus 2, that is equal to 1 by Z square into G Z minus F0 minus F1Z minus 4 times this sigma for this, that value is 4 by Z into G Z minus F0 plus 3 times of this G Z is equal to 0. Then we put the values given of the given conditions, that is F0 and F1, and then by applying the binomial theorem we can solve this recurrence relation. There is was the only these two steps, they were different from the previous problem, otherwise it is the same. So that's about the generating functions which we discussed. Values of the n less than and values of the n greater than 0 in the both cases. Rather, these cases are very typical and hard, but if we will consider them systematically, we can solve them very easily. That's okay for the recurrence relations.